Use centered rectangles of width 0.5 to estimate the following. So you can see that we have the integral from 0 to 2 of x cubed dx. So we think about x cubed. What we're saying is if that's 2, and a bit later on we've got 4 in here. So what we're saying here is integral 0 to 2, which would be this shaded area here. The next part is 2 to 4, which would be this area here. And then we're doing the integral from 0 to 4. So what we're showing is that that's going to give us the same result as these two added together. So it's the first of our properties, the integral from a to b. I won't bother writing all the f of x in, plus the integral from b to c, it's got to be the same function of course, is equal to the integral from a all the way to c. That should be the result of doing this. So if we just spend a minute setting up this first one, and then I'm going to assume that you know what I mean for all of the others. So I'm going from 0 to 2, which means if the width is 0.5, these will be the bounds for our rectangles. So we're going to have a rectangle here, and then there'll be a second rectangle there. And the heights of those rectangles are going to be the value at the center. So in other words, 0.25. But then the next center, because the widths are 0.5, is going to be at 0.75, which is of course 0.25 plus 0.5. So if we look at that on the calculator, so the width of my rectangles is 0.5, and then I've got 4 rectangles, so I've got y equals 1 to 4. The first one starts at 0.25. When y is 1, that will just be 0.25 because we'd have 0 times 0.5. But when y is 2, we'll have 0.25 plus 1 lot of 0.5, which is 0.75. So we get the correct starting value. So that's 0.5 times the sum of the heights of the rectangles, which gives me 3.875. So let's write that in here. So this one is 3.875. The true area is 4, as we'll see in a moment. Now what I'm going to do for the next one is I'm actually just going to copy that line and paste it down here. And if we think about going from 2 to 4, then my first one starts at 2.25. It's still going to be 4 rectangles. So I'm just going to change this to 2.25, and then it should work. So that one will be 59.625. And then for the last one, that's going all the way from 0 to 4. So if I paste again, all I've got to do is make it 8 rectangles and it will span the full width. And that gives me 63.5. And so, if I do that, plus that, it gives me 63.5. So it's true, according to this, that this and this gives me this. Now I know we haven't looked at how to actually do the integrals, but of course we could do that with the integration function here. So we could go 0 to 2 of x cubed dx. And as I said before, the exact area was 4. And I could drag that to there and just do it instead from 2 to 4. And that's 60. So together they're 64. And let's just drag this here and make the bottom one a 0. And there it is, 64. So that first property is correct according to the example we've done. And in fact, that does apply generally. It will always be correct.